Hello guys, welcome back to my YouTube channel. I am back with another video on data science lecture series. In this video, we are going to learn about regression modeling. Regression modeling in data science is a statistical method used to estimate the relationships between one or more independent variables, which is also known as predictors or features, and a dependent variable, also known as the outcome or target. It is one of the most commonly used techniques for predictive modeling. So let's take an example of a boy who goes to play outside or does not go. So he goes to play or does not, it is a dependent variable and it depends on whether the day is windy, sunny, it is raining outside or not. So all these are independent of each other, windy, rainy, and sunny. But he goes to place or not is dependent on these features. So this is example. Uh, we can train a model to predict whether the boy will go to play or not on a particular day. So, what are the key objectives of regression modeling? Prediction predicts the value of dependent variable based on the independent variable. Explanation understanding the relationships between the dependent variable and independent variables. And forecasting estimate future values based on trends and patterns in the data. Now, regression modeling, model evaluation. First one is metrics for evaluation. Evaluating regression models involves assessing how well they predict the target variable. मतलब जितने अच्छे predict करेगा उतना अच्छा मॉडल होगा. So common metrics include mean squared error, mean absolute error, and R squared. So mean squared error और mean absolute error जितना कम होगा उतनी अच्छी prediction accuracy होगी. और while a higher R squared suggests a stronger fit between the model and the data, then it is very important to choose the right metric for model evaluation. It depends on the specific problem and desired balance between bias and variance. A thorough understanding of these metrics is crucial for selecting the best model. Now let's look at evaluation metrics. First one is mean absolute error. It is the average absolute difference between predicted and actual values. Mean squared error, the average of square differences between predicted and actual values, and the root mean squared error, the root square root of MSE, providing error in the same units as the dependent variable. R squared, statistical measure that represents the proportion of variance for the dependent variable that's explained by independent variables. Now let's look at stepwise regression. What is stepwise regression? It is a technique for selecting the most relevant features in the regression model. It iteratively adds or removes features based on their contribution to the model's performance. So as you can see, as the name suggests, stepwise. So it adds features only one at a time, selecting the feature that improves the model's fit the most. And so for backward elimination also, it removes features one at a time, removing the feature which has the least impact on the model's fit. And hybrid approach is also there, which combines forward selection and backward elimination, iteratively adding and removing features based on their significance. Okay, let's have a look at the sample code of linear regression. First, we are importing linear regression from sklearn.linear model for training the model. Then importing matplotlib.pyplot.plt to for plotting. Then this is the sample data set in which x is independent variable and y is a dependent variable. Then we are creating and training the model. Model equal to linear regression and model dot fit x and y. We are fitting the model with independent and dependent variables. Then we are predicting, then we are plotting the results, and let's move on to our Jupyter notebook. Okay, so this is the sample code. You can see it. Importing a linear regression. Then this is the sample data, independent variable, dependent variable. Then we are creating and training the model, and we are making the predictions and plotting the results. Let's try to run it. Now you can see that this is the predicted, and these are the actual points. Predicted by a red line and actual points by blue dot. So this was the example of linear regression. Now let's move with a presentation. Okay, now let's look at the applications. First one is predicting house prices. So regression models are widely used in real estate to estimate the price of house based on various features. So the dependent feature here is the price of the house. एंड फीचर्स विच आर इंडिपेंडेंट इज मतलब घर में कितने बेडरूम्स हैं, कितने बीएचके का घर है, कितने बाथरूम्स हैं, कितने स्क्वायर फुटेज में वो है जगह, और लोकेशन कहाँ पे है, मतलब सिटी सिटी में है कि बाहर कहीं है, और प्रॉपर्टी कितनी पुरानी हो गई है, और आसपास सुविधाएं कैसी है, मतलब एयरपोर्ट अवेलेबल है कि नहीं है, रेलवे स्टेशन है कि नहीं, ट्रांसपोर्टेशन फैसिलिटीज कैसी है. सो ऑल दीज आर इंडिपेंडेंट वेरिएबल्स, and their depending variable is the price, which depends on all these variables. So we can predict the housing prices based on these features, and we can also train a model. And second is modeling risk factors in finance. So when a loan applicant applies for a loan, then the one approving looks at the features like credit history, loan amount, interest rates, and previous loan history. So, so regression helps assess risk and predict outcomes in fields like credit scoring. So that's it for now. मिलते हैं अगली वीडियो में. Till then, keep learning, keep exploring, and thank you for watching.